everyone. Today I'm going to take a lecture of operation research and our chapter number 3 queuing theory, and topic is queuing theory examples. So in our previous session we have already seen in the different types of the queuing theory problem. So our next example is in a service department managed by one server. On an average, one customer arrives every 10 minutes. That means a service department managed by one server. On an average, one customer arrives every 10 minutes. In every 10 minutes, the one customer arrives. Okay. So it has been found out that each customer requires 6 minutes to be served. Find out the number one, average queue length. Second is average time spent in system. Next is probability that there would be two customers in queue. That means in this question, every 10 minutes, one customer arrive, and it has been found out that each customer required 6 minutes to be served. That means one customer, the service rate 6 minutes per customer, and the arrival rate 10 minutes per customer. Okay. So in arrival rate and service rate, both the units are same, minutes. So we use as it is arrival rate in minutes and service rate in minutes. And if you convert into the hour form, so it's okay, both are correct. You use the minutes form or hours form, but both the units are same. So first one, we find the average queue length. So starting from number one, we write the arrival rate and service rate. This is very important points in every queuing theory problem. First, we find out the arrival rate and service rate. After that, we check the unit of the arrival rate and service rate. So here, arrival rate lambda is equal to 1 by 10 customer per minute. Because of here, every 10 minutes, one customer arrive. So in 1 minute, 1 by 10 customer arrive. Got it? Service rate mu is equal to per customer 6 minutes service rate. Okay, so 1 minute, that means 1 by 6 customer per minute. So here service rate mu is equal to 1 by 6 customer per minute. Got it? So first we find the row utilization factor or traffic intensity, in other words. So row is equal to lambda by mu. That means we put the value of the lambda and value of the mu. So the value of the lambda is equal to 1 by 10 and value of mu is equal to 1 by 6. So we put here 1 by 10 divided by 1 by 6. That means rho is equal to 6 by 10 is equal to 0.6. That means our utilization factor is equal to 0.6. Okay, so next, first we find the average queue length. So average queue length LQ is equal to, the formula is rho square divided by 1 minus rho. See, so we put here the value of the rho, and the value of the rho is what? 6 by 10. That means 0.6. So we put here the value of the rho 0.6 whole square divided by 1 minus 0.6. That means 1 minus 0.6 is equal to 0.4, and the numerator 0.6 whole square. That means 0.6 into 0.6 is equal to 0.36, and in the denominator 0.4. So we get the value of the 0.9, and here the average queue length. So we find the LQ, that means the number of customer. So we write here 0.9 customer, but we write here properly answer. So in the approximate one customer. Got it? Next one is the average time spent in system. That means we write here the WS. So in every question you read carefully, we find the average number of customer, number of system, total spent time in the system. So always you write clearly LS, LQ or WS or WQ. Okay, so average time spent in system, so we write here WS is equal to 1 upon mu minus lambda. So we put here the value of the mu is equal to 1 upon 0.167 minus 0.1. Why we write here the mu is equal to 0.167? Because of our value of the mu is equal to 1 by 6 and the value of the lambda is equal to 1 by 10. That means lambda is equal to zero point 0.1 and mu is equal to 1 divided by 6. That means 0.166. So we consider the 0.167. So the value of the WS is equal to 1 upon 0.167 minus 0.1. So solve this step and we get the value of 14.92. Okay, so this is the average time spent in system WS. So we write the approximate value 14.92, that means 15 minutes. Okay, our next is we find the term is, next is the probability that there would be two customer in queue. Okay, so what is the formula of the two customer or three customer or five customer in the queue? So always keep in mind the formula is P2 because of two customer in the queue. So we write here P2 is equal to row square into 1 minus row. Okay, so we put the value of the row. So value of the row is equal to 0.6. So we put here 0.6 whole square in the bracket 1 minus 0.6 is equal to 0.144. That means two customer in the queue. So we write here P2 is equal to row square 1 minus row. So put all these values. That means we put the value of the row only. So 0.6 whole square in the bracket 1 minus 0.6 is equal to 0.144. So this is the different types of example based on the queuing theory problem. So our next very important point is the classification of queuing model. So using Kendall's notation, sometimes a question given in the form of write the Kendall's notation. Okay, so using Kendall notation, the queuing model can be defined by in the bracket A slash B slash C, bracket close, we write here the sign of the colon, and D slash E. So what do you mean by the A, B, C, D, E? This is the Candela notation. Okay, so A is equal to arrival rate distribution. Okay, B is equal to service rate. C is equal to number of servers. That means in the first number is arrival rate, second is service rate, third is the number of servers. Got it? D is equal to capacity of system and E is equal to service discipline. That means always keep in mind in the first place arrival rate, second place service rate, third one is the number of servers, fourth in the place of D capacity of system, and E is equal to service discipline. This is very important for the Candela's notation. So example is, you define this example. Example is in the bracket capital M slash capital M slash 1, such that we write the colon in the bracket infinite slash FCFS. Okay, so what do you mean by the according to our Kendall notation? So meaning is arrival follows Poisson distribution, because of first one is the arrival rate, Poisson service rate, second one is the service rate, single server, because of here we write the one. Okay, one, that means single server. Okay, next in the place of D we write the infinite, so system can accommodate infinite number of customers. Okay, and FCFS, that means first come first serve, and service discipline is first come first serve basis. So sometimes in the place of the discipline, we write the first come last serve. That means FCLS. So we write here first come last serve. Okay. So I will continue this topic in our next lecture. Thank you for watching this video.